Okay, November 2022, paper 3, variant 1. Okay, question 1. Figure 1.1 shows a measuring cylinder containing some water. State the volume of the water in the measuring cylinder. Can I find the volume of the water in the measuring cylinder? Yes. Okay, from the reading, it's just above 20, and it is 21. Yes, 21 centimeters cubed. Yes, thank you. 21 centimeters cubed. Question B, he's asking a student adds 20 drops of water to the measuring cylinder. The new volume of the water is 25 centimeters cubed. Calculate the average volume of one drop of water. Volume of one drop of water. So what's the new volume? It's 25 and the old volume was 21. The old volume was 21. Can I find the difference in the volumes? Yes, I can find the difference. It's 24 minus 21, which is 25 minus 21, which is 4 centimeters cubed. Minus 21, which is 4 centimeters cubed. So this is the difference in the volume. Can I find the average volume of one drop? How can I find the average volume? Uh, Divide. Yes, we will divide. Should I divide 20, which is the number of drops? Okay. Should you divide 20 by 4? 20 divided by 4 or 4 divided by 20? What do you think? Should I divide 20 over 4 or 4 over 20? I think, yes, I think it should be 4 over 20. Yes, 4 over 20, which would give you an average volume of 0.2 centimeters cubed. A student has 20 over 4 would be wrong. Why? Because that's the number of drops per centimeter cubed. You need the volume of one drop. The volume of one drop. Okay, so volume of one drop in centimeters cubed would be 4 divided by 20. A student has a measuring cylinder and a small irregularly shaped piece of metal. Describe how the student can find the volume. How can he find the volume of the metal? Finding the volume of the metal, we said this experiment several times before. First of all, we need some water. He said he has some water. So add some water to the measuring cylinder. Add water to the measuring cylinder. Yeah, MC. You know, measuring cylinder is MC. And then take the volume. Take the volume, which is V1. Volume 1. Then add the metal or add the irregularly shaped object. Add the metal to the measuring cylinder again. And take the new volume. New volume. And we can name it V2. So we have V1 and V2. And the volume of the metal. Volume of the metal should be V2 minus V1. The difference between the two readings. The difference between the two readings would be the volume of the metal. Okay. 4 marks. That's a lot. 4 marks is a lot. It's 5% of your total paper 3 grade. We have a car. Calculate the resultant force and the direction of the force on the car. Can I find the resultant force and the direction? The resultant force would be subtracting. I can subtract 1200 minus 900, which would be 300. Direction would it be forward or backward? Or direction would be forward or to the right. Forward or to the right. Yes. A student uses a digital stopwatch to measure the time taken for the car to travel 100 meters. When should I subtract? You should subtract if the forces are in opposite directions. If the forces are in opposite directions, you should subtract. If they're in the same direction, okay, you should look at the arrows. If they are in the same direction, then you should add them. Okay. Can I take the time? Can I read the time? 7 point. 7.2 seconds. Yes, 7.2 seconds. That's it. Okay. What about the speed? Can I find the average speed? Yes. Average speed. You have to write down the equation. Average speed equals total distance over total time. The total distance traveled was 200 meters. The car takes 12.8 seconds to travel 200 meters, so it's 200 divided by 12.8. 200 divided by 12.8, you can use a calculator, which would be around 16 meters per second. 16 meters per second. Figure 2.3 shows a speed time graph. Speed time graph. Calculate the distance traveled by the car between 2 and 6. Not the whole distance. He doesn't want the whole distance. He wants the distance traveled from 2 seconds to 6 seconds. 2 seconds to 6 seconds. Can I draw the speed time graph? He wants the distance. This means that I should calculate. Should I say distance equals speed times time? Should I say distance equals speed times time? Definitely not. You should find the area under the graph. So the area under the graph would be from this part all the way to this part. And this is an area of a trapezium. Yes, it's a trapezium. Yep. Area under the graph. You should write it down. Area under the graph. Okay. Base 1 plus base 2 over 2 times height. What is base 1 and what is base 2? Base 1 and base 2 are the two parallel bases. The two parallel bases, which is this red line and the other red line. Okay. This red line was from 0 all the way to 6. So base 1 is 6. And base 2 is all the way up to 18. So base 2 is 18. This is 6 and 18. 6 plus 18 times the height, which is the difference between them, 4. 6 minus 2 is 4. It's not because 4 is in the middle, okay? It's because 6 minus 2 is 4. Okay, you can use a calculator to find the answer. The answer would be around 48 meters. 48 meters. Okay, yeah. Area under the graph. Height is the difference between the two. It's the distance, not the difference. It's the distance between the two parallel bases. We want this distance. So this line, which is this red line, it started at 2, and this red line ended at 6. So the difference between them is 6 minus 2, which is 4. So this base, this height is 4. A sailor uses a winch to raise a sail. Is applying a moment. Can I find the moment? Yes, moment equals moment equals force times perpendicular distance to the pivot. Force times perpendicular distance to the pivot. Yeah, you have the force and you have the perpendicular distance 90 degrees. So not 200 times 30, which is 6,000 newtons dot centimeters. Uh, okay. Describe two useful energy transfers when the sailor uses a winch to raise the sail. To raise the sail. Two energy transfers. You need from something to something, from one type of energy to another type of energy. Okay? From what type of energy to what type of energy? First of all, if you think about it, the sailor himself, gravitational potential to kinetic, no, not gravitational to kinetic. You can say kinetic to gravitation, not gravitational to kinetic. Why? Because he is raising this sail. He's raising this sail. It's moving upwards. So you have to say kinetic to gravitation. Yes, this could be one of them. Another one is if you think about the energy stored inside the sailor. Inside the sailor is chemical. Yes, thank you. So you can say chemical to kinetic. Chemical to kinetic. Okay. Winch is the is this device, okay? This device which can help him raise the sail easily. Okay, it's a device which uses the moment. Okay, it uses the effect of the moment. Yeah, chemical to kinetic, and then you can say kinetic energy to gravitational potential energy. Describe one non-useful energy transfer when the sailor uses the winch to raise the sail. Non-useful. These were useful energy transfers. Non-useful energy transfer would be what? Hmm. Thermal. Yes, something to thermal. You can say chemical to thermal, kinetic to thermal, whatever. You need to say that there is thermal energy, okay, lost. Okay, thermal energy lost. So you can say chemical to thermal or heat, definitely. Uh, Kinetic to thermal. Thermal energy lost to the environment. Can I find the weight of the object? Yes, I can find the weight of the object. Weight equals weight equals mg. So weight equals m times g. The mass is 5 kilograms and the g is 9.8. 5 times 9.8 is 49 newtons. 49 newtons. Okay. Um. Okay. Gravitation potential energy. Can I find the gravitation potential energy gained by the object? Can I find the gravitation? Yes, I can find the gravitation potential energy. Yeah, Mr. Bistahna, we are not required to find or to calculate the actual gravitation potential energy. Yes, you're not required to calculate the gravitation potential energy. Okay, because the equation, you're not required to know the equation. You're not required to know the equation. How can I solve this question? How can you solve this question? It's worth 1 mark. It's only worth 1 mark. If you think about it, he does 75 joules of work on the object in lifting it onto the table. Okay? He does 75 joules of work. And work done is one type of energy, one type of useful energy. So if you think about it, you don't actually need to calculate it using the equation. The whole notion of the work done on the object is the gravitational potential energy on the object. He lifted the whole object. He applied a force on the object and he lifted it some distance. So this is the gravitational potential energy on this object. It is the same as the work done. So all you need to say it's 75 joules. That's it. 75 joules. Okay. The weight of the table is 280 newtons. The table has 4 legs. The area of each leg is 18 centimeters squared. Calculate the pressure on the floor and give the unit. Pressure equals force. Yes. Pressure equals exactly. Pressure equals force over area. What is the force? Force is 280. What is the area? Yes, exactly. The area is 18 times 4. 18 times 4. Why? Because it has 4 legs. So 280 divided by 18 times 4, which is 3.9. 3.9. 3.99. What is the unit? What is the unit? Unit area, force over area, which is Newton per centimeters squared. Newtons per centimeters squared. 5 marks. 5 very easy marks. Okay, question 5 has been removed. You're not required to answer question 5. Okay, A, it has been removed. We can solve part B. Okay, we can solve part B. Describe some gas is trapped in a cylinder fitted with a movable piston. Describe how the gas exerts a pressure on the cylinder. Use your ideas about molecules. How do gas molecules exert pressure on the cylinder? If you think about it, gas molecules move. How do they move? They move fast and random in all directions. They move fast and random in all directions. What do? They hit the walls. They hit the walls. They collide with the walls. Um, you're saying they collide more often, which is okay. I'm not asking about whether when the temperature increases or decreases or whatever. I don't care about that. I'm just asking how does it actually create a pressure? How does it exert the pressure? So when the molecules move fast and random, they collide with the walls. They hit the walls, ca- causing a force. When they hit the walls, they cause a force over an area, which is pressure. That's it. Molecules move fast and random. He's not asking how does the pressure increase. He did not ask that yet. If he asks if the pressure increases or how does the pressure increase, yes, you can say the molecules hit more often, they hit with a larger force or whatever, or more frequently. You can say so. But for this question, he's simply asking how do they even create or how do they even exert this pressure? They move fast and random in all directions, colliding with the walls. Okay, colliding. With the walls, exerting a force, exerting a force over an area. And we know that force over area is pressure. Force over an area is pressure. هنا. Now, what happens? This question, if you can see the difference between figure 5.2 and 5.3, the piston moves and increases the volume. When the volume increases, now we can say what happens to the pressure. As he's saying that the temperature remains constant. The temperature remains constant. Yes, exactly. The pressure decreases. The pressure decreases. Why? Because we know as the volume increases, what happens to the pressure? Pressure decreases because they are directly or inversely proportional. Yes, inversely proportional. So you have to say that the pressure decreases. The pressure decreases. In terms of molecules, you can say that the molecules hit the walls. We can say hit the walls slower. Can you say that they're hitting the walls slower? No, you cannot say so. Why? Because the temperature is constant. The temperature is constant. So they hit the walls. Yes, they are hitting the walls, but less frequently. Less frequently. Molecules hit the walls. Again, please, you have to say they hit the walls. Never, ever, ever say that they hit each other. I know that they might hit each other. Okay, that is a possibility. But if molecules hit each other, that does not exert any pressure. That doesn't create any pressure whatsoever. So they hit the walls. Okay, they hit the walls less frequently. Okay, they hit the walls less frequently. Okay. Hmm. A student investigates wave properties. Yalla, the wave is moving from deep water to shallow water. What is the name of the effect? The name of the effect, is it diffraction? Is it diffraction? Or is it uh, refraction? Yes, refraction. Because it's bending. Okay, when the waves bend, they refract. That's the meaning of refraction, bending of the waves as they pass from one medium to another. When the wave passes from deep to shallow, two of its properties change. Describe how one of these properties changes. Okay. Someone's asking what is diffraction. Diffraction is when it passes through a gap, narrow or wide gap. Um, okay, as it passes from deep to shallow, you can say wavelength. Yes, wavelength has changed, or you can say the speed has changed. Okay, for example, if I say that the speed, okay, the speed has changed. What happens to the speed? It decreases. Speed decreases. But what if I say the wavelength? What if you say the wavelength? It also decreases. No, as it's passing from deep to shallow, it passes from deep to shallow, you can see quite clearly from this figure, the wavelength in the deep section, in the deep part, was larger than the wavelength in the shallow part. So as the wave moves from deep to shallow, the wavelength decreases and the speed decreases. What about the frequency? Can someone say the frequency changes? Can I say that the frequency changes? No, you cannot say that the frequency changes. The direction, yes, you can say the direction. Okay. But in this question, it would be a bit more difficult to say the direction. Okay. Sometimes, yes, you can say that the angle changes. The angle of refraction, yes, is less than the angle of incidence. Okay. Which is okay, but it's not, if you think about it, it's not a definitive property of the wave. It's not a definitive property of the wave. The speed and the wavelength, we can find the speed, we can calculate the speed, we can calculate the wavelength using the equation speed equals wavelength times frequency. You can find it easily, but it would be a bit more difficult to find the angle of incidence and the angle of refraction. Can I find the frequency of waves? Ah, can I find the frequency of waves? What is the frequency? Yes, the frequency, the equation of the frequency is the number of waves, number of waves over, number of waves over the time taken. The definition of the frequency is the number of waves per second, number of waves over the time taken, which is 25 over 10, which is 2.5 hertz. 2.5 hertz. Waves on the surface of the water are transverse waves. State one other example of a transverse wave. State one other example of a transverse wave. What are other transverse waves? If you think about them, transverse waves are sound is not a transverse wave. Light waves. Yes, you can say light waves are transverse wave. Any electromagnetic wave, X-rays, gamma rays, any electro, but sound is a longitudinal wave. That would be wrong. Describe the vibration of particles in transverse waves. In transverse wave, they vibrate up and down or left and right. They have to vibrate, vibrate up and down, perpendicular or parallel to the energy motion. No. Yes, it is perpendicular. Perpendicular to the energy motion. Excellent. يلا. A student has a bar magnet in the metal bar with ends X and Y. The student moves each pole of the magnet in turn to be close to X and Y. Okay. It attracted at X. It attracted at X attracted at the North Pole and repelled at the South Pole. State and explain what can you deduce about the metal bar. What can we deduce about this metal bar? Huh. Metal bar. Is this a normal metal bar? Is this a normal metal bar? X. Yes, X is a south pole. Excellent. X is a south pole. So this is south pole. So it's a. Is it a permanent magnet? Yes, it is a permanent magnet. Permanent magnet. X is a south pole. Okay, since it repels. Okay, the south pole of the magnet. The south pole of the magnet. Okay. We have a bar magnet. We have two bar magnets. Describe an experiment to show the pattern of the magnetic field between the bar magnets. Pattern of the magnetic fields between the bar magnets. Describe an experiment to show the pattern of the. Can they be attracted? They can be attracted. Can they be repelled? They can be repelled. But the question is, he didn't state which poles do we have. He's asking to find the actual the lines, the field lines. Yes, use a compass. Thank you. Use a compass. Using a compass, what should we do using this compass? We need to move this compass, place this compass in several positions around the magnet, and then at each position draw an arrow with the direction of the north pole of the compass. Use a compass, or you can say place a compass in several positions. Okay, place a compass in several positions around the magnets and around the magnets, and at each position at each position draw an arrow draw an arrow with the direction with the direction of the north pole of the north pole of the compass. Again, place a compass in several positions around the magnet. I'm sorry, my handwriting isn't the best. Okay, around the magnet. And at each position, draw an arrow. Okay, draw an arrow with the direction of the north pole of the compass. And then you can just join the lines when you're done. Okay, join the lines. Okay, yeah, figure 8.1 shows an electric circuit set up by a student using standard symbols. Draw a circuit diagram for the student's circuit. Okay, we have a switch, we have a battery, an ammeter, a lamp, and a 15 ohm resistor. It's quite clear that they are all in series. It is clear, isn't it? They are all in series. A battery, switch, it's all the same loop, it's all the same wire. We don't have several branches for this wire, so it's they are all in series. Can I draw them? Yes, I can draw them. The battery, we have the battery. Okay, so this is the positive end of the battery, and this is the negative end of the battery. This is an open switch and an ammeter. Okay, a lamp, a 15 ohm resistor, and that's it. Okay, okay, yeah. When the switch is on, state the name of the particles flowing in the metal. Yes, in the metal wire, they are electrons. They are electrons. Thank you. The current in the 15 ohm resistor is zero point 0.4. When the switch is closed, calculate the potential difference across the 15 ohm resistor. What is the potential difference? What is the potential difference? Can I find the potential difference? Yes, the voltage V. V equals IR. V equals I over R. No, it's not I over R, it's IR. Ah, V equals IR. So basically the current is zero point 0.4 times the resistance 15, which is 0.3. Which is, I'm sorry, 6 ohms, which is 6 ohms. 6 volts. This is the voltage or the potential difference across the resistor. Okay? Okay. Yeah. Figure 9.1 shows a transformer used on a building site. Give a reason why the plug includes a fuse. Why the plug contains a fuse. So what does a fuse do? Hmm. What does a fuse do? A fuse protects the circuit from overheating. It's for our safety. Basically, the fuse is for our safety, isn't it? It's for our own safety. So it protects it from overheating. Protects, okay, so it protects from overheating. Um, Explain how the fuse works. How does the fuse work? When what happens? What happens when the current increases? if the current increases, yes, above a certain amount, above a certain amount, it melts, it melts and breaks the circuit. Okay, melts and breaking the circuit. Okay, fuse will melt and the circuit will break. Okay, good. Means input primary potential difference is 230 volts. Number of turns on the primary is 314. The number of turns on the secondary is 150. Can I find the output voltage? Can I find the secondary voltage? Yes, I have one equation. Okay, I will use one equation, which is VP over NP equals VS over NS. So VP 230 over NP 314. Okay, equals Vs, which is the output voltage, and Ns, which is the number, which is 150. Cross multiplication, 230 times 314 divided by 230 times 150. This is 230 times 150 over 314, which would be 110. 110 volts. I. Can I repeat I? Fuse, what does a fuse do? If the current increases above a certain amount, so for example, if I say that the rating of this fuse is 5 amperes, meaning that if the current is above 5 amperes, what will happen to the fuse? It will melt. When it melts, it cuts off the circuit. It cuts off the current from ever reaching the device. The current will not reach the device. Why? Because this device only operates at a certain voltage or at a certain current. If you increase the current, the problem of too much current is that it overheats the device. It overheats the wire itself. So the wire itself could melt. Okay. Hmm. The suitable material for the core is iron. Yes, thank you. It is iron. Suitable material for the coils. Yes, the coils. It is copper. Excellent. Okay. Um, how does it show? This is a step down transformer. Okay, it has more coils. What has more coils? More input coils. Yes, a primary has more input coils. Okay, primary, or you can say that the secondary, okay, the secondary coil has less turns. Excellent. Okay, moving on to question 10. Type of radiation and the characteristics of this radiation. Okay, indicating with a tick the correct type of the radiation for each characteristic. So the gamma rays, he said that it is an electromagnetic wave. Okay, it is an electron. The least ionizing, which is the least ionizing? Yes, the gamma rays as well. Which is the least penetrating? It is alpha. بالظبط. Which is a helium nucleus. Helium nucleus. It is, yes, an alpha particle. And last but not least, the negatively charged particle is the beta particle. Basically, it is an electron. It is an electron. So we have plutonium, 94 protons, 147 neutrons. The symbol is Pu. Can I write down the nuclide notation for this nucleus? Yes, it is easy. Well, the nuclide notation would be Pu. P4? No, it's Pu. Pu. With the number of protons, we write the number of protons. 94. Can I say 147? Can I write down 147? Would that be correct? Definitely not, because you need to find the nucleon number or the neutron or the mass number, not the neutron number. You need to find the mass number, which is 94 plus 197. 94 plus 147, 94 plus 147, which would be da, 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 241. 241. This is the nuclide notation of polonium. Sample contains 8 times 10 to the power of 12. The half-life is 14 years. Calculate the number of atoms remaining after 28 years. Well, after 28 years. How can I find it after 28 years? First of all, you need to say how many half-lives do we have? How many half-lives are there? Uh, Half-lives. First of all, half-life means it's the time taken for the amount of radiation to decrease, or the amount, or the mass, or whatever, to decrease to half the previous amount. Again, the amount of radiation or the mass or whatever, okay, uh, radioactive decay, to decrease to half the previous amount. This is what I mean by half-life. So it takes 14 years to divide by 2. It takes 14 years for the amount to be divided by 2. Okay? How many 14 years are there in 28 years? That's the first question you should ask yourself. How many 14 years are there in 28 years? So first of all, 28 divided by 14 is 2 half-lives. Meaning, what do I mean by 2 half-lives? I will just write it down for yourself. Divide by 2, how many times? 2 times. Divide by 2, how many times? 2 times. What is the number that we will be dividing by 2? The total mass, the total amount of radiation, the initial number that you have. Okay, so we will divide it by 2. How many times? 2 times. So 8 times 10 to the power of 12 divided by 2 is 4. Divide by 2 again is 2. So the remaining is 2 times 10, or the remaining mass or remaining number of atoms is 2 times 10 to the power of 12 atoms. That is the remaining amount of atoms in the isotope, in this isotope. Okay?